Hello there, I'm Mesra Kantarcı. I'm a student in Computer Science Engineering at Akdeniz University and welcome to my presentation on natural language processing. Let's start with a question. What would happen if we could use 100% of our brain? Breaking news everyone, it seems like we are already using it in that way and this research says that Hollywood is wrong and we actively use our entire brain most of the time. So this is the best we can. Okay, sorry to inform you. However, what would happen if machines could use 100% of the data on the internet? Now this is a good question. Computers are very good at learning from clean, structured, and normalized data, especially numbers. For example, they can easily process and analyze data presented in datasheets within the rules and calculate very complicated equations in seconds. But when it comes to humans, our ability is not as good as computers' own calculations. For example, we may need more than seconds even when the multiplication passes two-digit numbers. However, there is one thing we can do better than computers: understanding the context. The machines can talk with ones and zeros, and humans can talk with words and sentences. The language we use when speaking is not as precise and final as the machines. For example, a code must not have a spelling or syntax error for it to run properly. However, people tend to make mistakes. So, how do we get the machines to understand us? Here I will answer these questions in this video. The oil of our period is data. In an introductory video of IBM's Watson, it is said that the 90% of the world's data is created past 2 years and 80% of it is unstructured. This means we cannot benefit from the most of the data on the internet. But what about those pointless tweets we wrote on Twitter, right? Everyone is making up their own comedy shows or telling the things that have never actually happened. Well, we are looking from a very small perspective. Actually, the tweets are not really pointless. For example, the feedback of the product lies in these unstructured sentences. Also, we should mention the books and documents we can use the context itself right now. Or the factors that caused the dollar price rise are also in unstructured data we mentioned. Let's not forget the science is cumulative and the world is linked together with cause and effect relationships. There is data waiting to be analyzed sit idle there. So this is why we need NLP. So what is NLP? NLP is about natural language processing. In order to understand and process the context of the language that people use. It is one of the subdivisions of artificial intelligence because it ultimately relates to the ability of the machines to make intelligent decisions or producing outputs, like analysis. Here is what you can do with NLP. Text classification, speech or text recognition, machine translation, question answering, information retrieval, automatic summarization, web search, grammar checking, sentiment analysis. Some of well examples of NLP solutions are Google Translate as machine translation example, Google Assistant, Siri, Alexa, Cortana as chatbots, IBM Watson as chatbot and question answering, Clevo as e-commerce market intelligence, Grammarly as spell checking, Reddit's Auto Too Long Didn't Read bot as automatic summarization. So, why natural language processing is important? For example, you can structure the unstructured data. You can understand the whole context without reading it. You can talk and interact with others in a language you don't know. You can solve your problems faster. If you are a product owner, you can find out what customers didn't like, or as in my future project, you can embed the words into the mathematical values or vectors in a vector space by considering the meanings of the words from documents which the computer can analyze it better. Okay, now I want to talk about the development and history of the NLP. Although the theories of this subject go back to Leibniz and Descartes, everything related to the machine context started with the famous question of Alan Turing in 1940s. Can machines think? You know the Turing test? Let me explain for those who don't know. You try to figure out whether the one you are talking with is human or machine by asking questions to the subject. It is inside of the boundaries of NLP since the machine should understand the question and deceive the questioner as if it is a human by answering the questions wisely enough to pass the test. In general, machine translation was very hard during this period. People tried to translate using bilingual dictionary, but they didn't really work because they were just word-to-word translations. In 1954, IBM introduced a machine that translates from Russian to English. In 1957, Noam Chomsky said in his Syntactic Structures, language is generative in nature. So he claimed that language and therefore sentences can be generated in a mathematical way. And he tried to explain it in linguistics. At this point, two types of trans emerged: NLP on linguistic-based rules and NLP on statistical-based rules. When we arrive in the 1960s, we see that the linguistic approach found more supporters. However, sadly, when machine translation didn't give the desired results, the fund was cut and machine translation researches were halted. You see, machine learning technology was not really economic or efficient in 1960s. What you see in the screen is 10 megabyte of hard disk from the time. Wow! In 1970s, William Woos tried to represent phrase structure rules with recursive finite state automatas. These yielded more successful results than the previous studies. The first chatbots like Eliza started to appear in this period. Increasing speed of the CPUs and capacity of memory and decreasing prices in the technology as the Moore's law had anticipated. In 1980s, NLP started to become trending again. People focused more on statistical approaches in their researches, and instead of trying to do it alone, computer science engineering and linguists started to work together. And NLP started to prove itself with IBM Watson in 1990s thanks to machine learning and internet. I think there is no one left who hasn't used Google Translate now. As you see, it is one of the most advanced and popular NLP solutions. So, despite all the developments in NLP technology, 100% of accuracy has not still been achieved. The reason for this, let's take a look at the challenges of NLP now. There are infinitely many number of ways to arrange the words in a sentence, so we can't give computers a dictionary of all possible sentences to help them understand what humans are talking about. So the first and fundamental method on NLP was the construction of the sentences into bite-sized pieces which could be processed easily. There are 4 stages to analyze the words and sentences: lexical, synthetic, semantic, and pragmatic. All those stages have one common enemy: ambiguity. Let's look at lexical stage, which is morphologically based analysis. Morphology is the study of the words and other meaningful units of language like suffixes and prefixes. I want to give a Turkish example because I am currently working on to solve this issue. Turkish language is agglutinative type of language. There are some words like Afyonkarahisarlaştıramadıklarımızdan mısınız? Or just a simple word, koyun. So, even though stripping the word is somewhat easy, the context itself can stay as a problem as we see in the koyun word. It may be a verb put, or sheep, or the breast. So, this issue also triggers a semantic problem too. For example, children make delicious snacks may be interpreted as kids prepare tasty snacks or children are very tasty when you eat them. Or let's eat grandma and let's eat grandma is different. So moral of the study, use punctuation. Although the context is better understood from what we see in the Google Translate now, the content containing sarcasm and irony is still not fully understood. With the new technologies and the data, we can also develop our own NLP. But before you start coding, you should take these primary requirements into consideration. You should have knowledge on artificial intelligence, statistics, linguistics, and psychology. You don't have to be an expert on these, but the better you know these subjects, the faster and more accurate you can develop your own NLP. After these basics, the main requirement you should do is understanding the problem correctly. For example, to count the colors in a novel, you shouldn't separate all the words in a novel by one lexically. You can create a color dictionary and search and match the versions of various suffixes, prefixes, and here you go, fast solution. You can do this task with machine learning or simply with well-written regular expressions too. However, when it comes to retrieving feedbacks, what you should do is sentiment analysis. So the tools and methods you will use will vary depending on the nature of your project. For this reason, you also need to master your problem first. What could you do in order to solve problem? Okay, I will say the fundamental NLP tasks: tokenization, word stemming and lemmatization, part of speech tagging, chunking, stop word removal, named entity recognition. First things first, tokenization, which is also known as segmentation, is a process of breaking text into meaningful smaller elements. These smaller elements are called tokens. They can be words, numbers, or even punctuation marks. Tokenization is an easy task, but let's not underestimate this task because most of the errors made in this phase will propagate into the later stages and cause problems. So, it is one of the most important tasks you should look into. The goal of stemming and lemmatization is to reduce the inflected or derived words form to its root base form. For example, MR is actually just verb be. Part of speech tagging is assigning labels for each token with its respective grammatical components such as noun, verb, adjective, or adverbs. This is crucial task for parse trees. The most popular and the most trained post taggers for English tag set is Pen-Treebank set. It is always good to know the tools so you don't have to discover America over and over again. Just use the proper tools, libraries, and save your time and effort. Chunking is a process that requires post-text input, and it provides chunks of phrases as output. Same as post-text, there is a standard set of chunk text like noun phrases, verb phrase, etc. Stop words are simply words that have little meaning and mostly used as a part of grammatical structure of sentences. Words like the, a, an, in, etc. are considered as stop words. Named entity recognition is a process of identifying entities such as names, locations, dates, organizations that exist in an unstructured example. It's a very important task when dealing with information extraction. Other applications where named entity recognition is used are classifying content for efficient search algorithms or chatbots and voice assistants. Now, what would you need to use if you were to start to NLP? As in machine learning, the most popular language in NLP are Python and R. In Python, there is a toolkit especially for beginners, Natural Language Toolkit, NLTK. NLTK is available for Windows, Linux, and Mac OS X. It is open source and free project with a broad library for natural language processing. You can tokenize and tag the texts, identify named entities, display parse trees with NLTK. In order to use NLTK, you should first install the Python, and optionally you should install NumPy as well. Then go to command line, check if your Python version is 3 or higher. Then write Python. Start coding Python at command line. Write this, import NLTK. Then nltk.download. Call this function. It will open a new window like this. The installed and up-to-date ones will appear in green, where outdated will shine in red and not installed ones will be in a boring gray color. Okay. Download them and let's try tokenization in command line. So, write from NLT tokenize import word tokenize. Then enter your sentences, hit enter, and it is tokenized now. Wow, this is very first NLP application. So, if you are a newbie in this area, I suggest you to play around NLTK. Let's summarize what we learned. NLP translates what people say into a content that machine can understand or process. We need NLP to be able to use unstructured data, improve our analysis, accelerate and automate the processes. Science is cumulative and we can understand our world better if we collect data around us. NLP is a technology which is used even when we are not aware of it. Whenever we use the written or recognized speech communication channels such as Twitter, Facebook, Instagram, Amazon, Google Assistant, Siri, it becomes a subject to NLP. However, it should also be noted that the information can be eventually used against us. The comments we wrote on social media are now turning us as advertisements. However, in future, with the change of perspective and behavior, the data may be used for tagging the people. Bad. Still, the development of science shouldn't be prevented because it can be abused by bad decision makers. The important thing is humanity should keep improving for the better and reach that mentality which should prevent these potential abuses. NLP technology continue to progress, especially with the increase of the CPU and memory capacity and increase of the data and tools. If you want to work with NLP but don't know where to start, you can choose Python language and NLTK as a start. There are plenty of information and free courses on internet. However, if you have a desire to develop NLP and you will not remain as a newbie, you will need good knowledge on linguistics, artificial intelligence, machine learning, math, probability, statistics, linear algebra. And you should do your literature research on your problem and possible solution tool before you waste your time and effort on something that has already been developed. You can also accelerate your work by implementing the libraries and tools on the internet. For example, with bidirectional encoder representation from transformers, as known as BERT, you can easily apply techniques such as classification, named entity recognition in Python. Global vectors, GLOW, which uses unsupervised learning algorithm for word representation, is also an available option for Python. So that's it. I really hope my natural language on this course was understandable and the context was not ambiguous. Thank you for your attention. Have a good day and stay healthy.